Hello everyone. In this lecture we are going to cover algebra part and basic of logarithmic also. So again we are studying here basic. So we'll study in algebra that much part only which is required in physics. So mainly we'll see that quadratic equation and some form of series like AP and GP are most popular. Okay, so that one we'll study only and some logarithmic basic concept of logarithmic. Okay, so in algebra first topic is quadratic equation. Quadratic equation. Any equation, if any equation is in this form, ax square plus bx plus c equal to 0, okay, where this x is variable, then this kind of equation is known as quadratic equation. That means one variable power 2. If in any equation highest power is 2 and that is variable, so this kind of equation is known as quadratic equation. So here x is variable and maximum power is 2. So this is quadratic equation. Okay. So this kind of equation is known as, this type of equation is known as quadratic equation. So here in quadratic equation, let's say if alpha and beta are roots of this quadratic equation, then alpha and beta will satisfy this equation. Satisfy this equation means if we put in place of x equal to alpha, then it will be 0 again. Okay, so let alpha and beta are roots of quadratic equation, then it will satisfy the equation. That means satisfy that equation means if you put in place of x alpha, so it will be alpha square plus beta into alpha plus a equal to 0. If you put beta, then it will be also a into beta square plus b into beta plus c equal to 0. So roots means it will satisfy the equation. Satisfy means you place in place of x alpha, place of x beta, so it will be 0. Means once you put in all x alpha or you put in place of all x beta, so it will be 0. That means this will satisfy the equation. Satisfy means replace x by that alpha beta, it will be 0 again. Okay. So here, if alpha beta roots, then it will satisfy the equation. So we can write like this. Then what is roots of this equation? So roots equal to roots alpha and beta are given by minus b plus minus under root b square minus 4ac upon 2. So here, once you will take positive, another time you take only negative, so there will be two root. One root, let's say positive, so this is b square minus 4ac upon 2a, and another one you can take minus b plus minus b square minus 4ac upon 2a. Okay, so these are roots of these alpha and beta are roots of this quadratic equation. That means if any equation is there like a, b, c, some constant, so we can find out alpha and beta value. This alpha and beta will satisfy this equation. So this is known as roots of equation. Okay, so here some important about these roots alpha and beta, whether it is real number, whether it is real or imaginary. So here nature of roots. So for nature of roots we will find out discriminant. So this discriminant is defined as d is defined as b square minus 4ac upon b square minus 4ac. Okay, so this discriminant d is defined as b square minus 4ac. Okay, so if if this is case number 1, if d is greater than 0, okay, then we will get here two roots, okay, then unequal two unequal root will get two unequal root, then two unequal roots, that means alpha and beta will be this one, this is alpha, this is beta, so we can get here alpha equal to same, then two unequal roots alpha and beta, okay. If d equal to 0, then we will get a common root. Common root means this alpha and beta both will be equal, okay. So here in this case alpha beta equal, okay, we'll get only one root, okay, because this part is 0, this part is 0, so here minus b upon 2a, that means this value will be minus b upon 2a, and here alpha will be this much, beta will be this much, okay. So I'm not writing again, this is alpha, this is beta, so this alpha and beta will get two value if d greater than 0, okay, this value will be positive, then we'll get like this. Third case, if d less than 0, then we will get imaginary root, we will not get real root, these roots are real possible. Here if this is negative, that means inside bracket, inside under root, this is negative, it is not defined, so then imaginary root unequal to unequal non-real root or imaginary root, imaginary root, okay. So this is how nature of this roots of quadratic equation. So if d positive, real root, and two unequal root, d0, then it will be both equal minus b upon 2a, d less than 0, then two unequal imaginary root, okay. So these are nature of these roots, okay. So here important is this formula. This formula is very important. You have to remember roots of quadratic equation is minus b plus minus under root b square minus 4ac upon 2a, and this nature, if d greater than discriminant greater than 0, unequal root, okay, we will get 2 root equal minus b upon 2a, unequal this is less than 0, then not possible, real root will not exist, imaginary root will exist, okay. So this is about quadratic equation, okay. So we will study little bit about series, okay. So in series mainly AP and GP, okay. So here in series we learn about arithmetic series, arithmetic progression, arithmetic progression series will also known as by AP, okay. So in arithmetic progression series, if there are any number like this, a plus d, a plus 2d, a plus 3d, dot dot, okay. So here this series is known as in AP, this series is known as in AP. So here common common difference, common difference is second term minus first term. So a plus d minus d, second term minus first term, this is always d. Similarly we can write here third term minus third term, a plus 2d minus second term, so d. So here difference of two consecutive term will be always same, and that is known as common difference, okay. So common difference here is d, that means two consecutive number you take at a time, so difference of consecutive number will be same, that is known as common difference, okay. So here important is if you want to find out nth term, okay, like if you want to find out here nth term, nth term, so let's say nth term is a, So an will be a plus n minus 1 into d, you can write here. Okay, like second term we want, second term, so put n equal to 2, so it will be 2 minus 1, 1 a plus d, we'll get second term. Similarly third term, so you put here n equal to 3, 3 minus 1 2 a plus 2d, will get third term, so on. So another term we can find using this formula. Second formula here is, if you want to find out sum of nth term, sum of nth term, then we can write here n by 2 in bracket 2a plus n minus 1 into d. Okay, so this is formula for sum of nth term. Okay, this is sum of nth term. That means you can add here n term and you will get this formula. Using this formula you can find out sum of nth term. Third, if I am saying that there are three numbers are in AP, if A, B, C are in AP, then we can write this second number equal to sum of first and third number upon 2. Okay, so second number we can write like first plus second, first plus third upon 2. Okay, completed this much. So next one is AP series. AP over. Okay. So next one is GP series. Okay. So geomet series. So this is geometric progression. So in geometric progression, again, how it is defined? If number are like A, second number A R, third number A R square, A R cube, so okay. So this number is known as in GP. Okay, so this is known as this series is in known as GP. Okay, so here common difference, common ratio is defined. This is common ratio. This common ratio is second term upon first term or third term upon second term. So ratio of two consecutive is known as common ratio. So here if I am writing AR upon A, so this is R. So this R is common ratio. Okay, this R is common ratio, or let's say in general if I am saying if A1, A2, A3 dot AN are in GP, then we can write R equal to common ratio A2 upon A1, or A3 upon A2, or A4 upon A3, or we can also write AN upon AN minus 1. Okay, so this is how it is defined. So common ratio is always next term upon first previous term, ratio will be constant. Okay, like 10th term upon 9th term, or 100th term upon 99th term. Okay, so this is defined here, common ratio. So in this one again we have to find out nth term, sum of n term, okay, and sum of infinite term also. Okay, this part is also over. So here this is common ratio defined as next term upon previous term ratio, that is R here. So here important is if I want to find out nth term, again nth term, so nth term here is an, that is equal to first term into r to the power n minus 1. So this is nth term. Okay, like let's say n equal to 2. So 2 minus 1, 1. So a into r to the power 1, that is ar. So second term is ar. Third term ar as well. So on. So this is how you can find out. This one is first term. This one is common ratio. Common ratio. Okay. Second, important here, sum of nth term. Okay. So this is basically, there are two formula here. Sum of nth term. So here Sm equal to first term r to the power n minus 1 upon r minus 1 if r is greater than 1. Comma ratio greater than 1, then we have to write here r to the power n minus 1 upon r minus 1. If comma ratio is less than 1, then we have to write 1 minus r to the power n upon 1 minus r if r is less than 1. Okay, so there are two formula for sum of nth term. Okay, so Sn, if r greater than 1, then apply this one. R less than 1, then you apply this one. And third one, let's say r less than 1, but number of series are up to infinity. So here for infinitive term, if r is less than 1, then sum of infinitive term we can write here a into, this is a upon, this is basically a upon 1 minus r. Okay, this convert. Okay, we can solve it. Okay, so all this derivation we will study in mathematics. Okay, so here sum of infinite term is a upon 1 minus r. So this is very important, you will use it. Okay, again and again. Sum of infinitive term of GP is a upon 1 minus r. Whatever is common difference, a upon first term upon 1 minus common difference. Okay, so this is important here. So this is series. Here also we can write that if there are, if three number A, B, C are in GP, then we can write this second number B equal to under root A into C. Okay. Similarly, you can check here. Second number you want, so multiply here a into ar square. It will be a square r square. You take under root a square r square. Under root will be ar. So second term. So if there are three number are in GP, then second number you can write b equal to under root product of first and third term. Okay. So this is about GP. Okay. So this much is used infinite term, up to n term, nth term, and series. Okay, so this is about G. Okay, complete it. So next one is logarithm. So in logarithmic again we'll study basic. Okay, so log is also used in physics. That's why we are studying this one also. Okay, so in logarithmic, let's say if there is a number like log ax equal to, let's say, log ax only. Okay, what is the meaning of this one? Okay, so if any number is there, two positive number, here condition is that this one is, if two positive number, if, let me define like this, if a and x are two positive number. For positive number only log is defined. Okay, so that's why I'm putting your condition first. So a and x are two positive number. Then log x base a is called as called as log of x to the base a. Okay, so if a and x are two positive number, then we can write log a x, and we will write it log of x to the base a, or with base a also we can say, or we can also write, also call it like this, log base a x, but most popular is log of x of base a. Okay, or to the base a. Okay, so this is how it is defined, it is called like this. Okay, so if I'm saying log ax equal to, let's say y. Okay, then we can write here, this is x equal to a to the power y. So both are same thing, both are same same thing, means both equation are true. Okay, both are same thing. Here if I'm taking log, so log base a x, it will be like this. Then log base a to the power y outside, it will become y only. Okay, so both are same thing here. Okay, so we can define here some important formula. Okay, so only we have to memorize some formula. So here, properties of properties of log, or we can say formula of log. Okay, so in log, how formula is defined. Okay, so here main property, if any number is there, you are taking log with the same base, means number is same, so this will be always 1. If you are writing log base anything 1, this will be always 0. Okay, so we can point out. Okay, formula. Third one, if there is log base a b, so here it will be log base b a. It will interchange, it will be reciprocal here, base and this value will interchange. Okay, so base b a, so this is known as log of a to the base b, log of base b to the base, log of b to the base a. Okay, so this is how we can call it. Okay, so fourth one is, if writing log m, so we can write here log m plus log n. Base can be anything. I have not written base, that means base can be anything. Generally log represent base 10 and ln represent base e. Okay, so this is log mn equal to log m plus n. Here log m upon n, that is equal to log m minus log n. If there is power of log, like let's say m to the power n, so we can write n outside log m. Okay, if I'm writing log a b, so I'm introducing one base c here, so we can write here log b to the base c and log log a to the base c. So here one base I'm introducing, so it will become log log of b to the base c, log of a to the base c. Okay, so we can write like this. Okay, next formula is power. Okay, so this is so next, if any number you see like this. Okay, like let's say base interchange. So base interchange means here, let's say if there is any number a and b. Okay, so here let's say this is some number c. Okay, So basically I am going to repeat this one. If A, B, C, so here this implies that this A equal to C to the A equal to B to the power C. Okay, so B to the power C. So this is mostly used. Okay, you have to remember it. Okay, otherwise if you are confused, then you can check, cross check. Log, you take both sides, it will become log A, it will be base B. You take log with base A. So base A, so it will be here. Uh, this will be C and this will be log base B. So this is like that. So if there is log A B equal to C, then we can write here, okay, similar to this one. Okay, so this will become power of this one. Okay, that means it will be B equal to A to the power C. And if you are confused, you take log. Okay, so you take log both sides uh, to the base A. So this will be log of B to the base A, this one, and this will become simply C. Okay, we can write like this. So most popular again here, natural logarithm. Okay, so natural law. Okay, so whenever if base of log is e, e is a number. Okay, e is a number which is just a mathematical constant. Okay, mathematical mathematical constant. This is mathematical constant and this value is 2.718. Okay, so this is mathematical constant. If base of log is e, which is mathematical constant, okay, then it is known as natural log. Then it is known as it is known as natural log. Natural log. Okay, and this is represented as and represented as ln x. Okay, ln x. So we will call it log of x with natural base, or log of x with base e, we can say. Okay, so here log base e x is shortcut written as ln x. So ln x means base e by default. If there is log x, so we are in doubt whether base 10 or base e or whatever is base. But if ln x written, so it will be only and only base e. Okay, so we can write here. Now you will see conversion of log base e to log 10 or log base 10 to log e. So let's say, important here, if log base 10, some number is given, let's say a. Okay, so we can write here ln means I'm writing here log base e a upon log base e 10, we can write. So this value is, we can write here log base e a. So we can write here this value is log base e 10. We have changed here this value. So this value is log base e a, log base e a. Okay, so this is how we can interchange, but mostly you will see if there is log of base e, we have to change with base 10, then we have to multiply by 2.7, like log base e given a. So we can write this one log log base 10 a upon log base 10 e, we can write. So this value is log base 10 e. This is log base 10 e. This value is something like 4.418. So if I calculate, it will become 2.3. Okay, so 3.30 something, 2.3 close we can take into log base 10. So here important formula is, if any number is okay with base e, we can convert with base 10, but we have to multiply with 2.3. Okay, so this is how we can convert. Okay, so here we can make it formula form, that log, this is important, log base ex, so we can write 2.3 into uh, 2.3 into log base 10 x. So this is you will use mostly. Okay, and this one is understood. Okay, base e means you call this one. So if there is any number with base e log, then we can convert 2.3 into same number with base 10. Okay, so log ex, log 10x. So here multiply with 2.3 and then you take log of that number with base 10. Okay, so this is all about logarithm. So this formula is important, this concept important, this formula once you go through it, okay, it's not difficult to remember. Okay, so this is all about logarithmic and algebra part. Okay, so next we will study about graphs and then differentiation integration. Okay, thank you so much.